Now let us derive a mathematical equation for the availability of a system. And to do that, let us assume that we have a system which is at a state 1 and it is going reversibly to attain the dead state, which is P0 and T0. Okay. So in doing so, let's apply the first law and the second law onto this particular process. So the first law states that Q minus W is equal to E2 minus E1. Let's give this as equation number 1. This is as per the first law. Simple. Now as per the second law, the entropy generation, this is equal to S2 minus S1 plus the heat loss to the surroundings by T0. This is equation 2. Okay. Now, because the heat is being lost to the surroundings, this would become a negative quantity. So I can say that Q surroundings is equal to minus Q. So let's put this over here, and this would now become the entropy generation is equal to S2 minus S1 minus Q upon T0. Okay, so this is, let us say, equation number 3. Okay, now from this first equation, let's get the value for W. So W will be equal to, because we want to find the availability, that's the maximum amount of work possible from a system. Okay, so W is equal to Q plus E1 minus E2. Okay, now let's look at this third equation. Let us say this is equation number 4. Okay, now as per the third equation, if you algebraically manipulate that, so let's get the value for Q from there. The value of Q from there is, let's take T0 on either side. So this would be T0 into the entropy generated, T0 as gen. This is equal to T0 into S2 minus S1 minus Q. So this is what you get, minus Q. And from this equation, let's get the value of minus Q. So the value of minus Q, or I would say, just find the value of Q right now. So the value of Q, it comes about to be T0 S gen. Okay, this is minus T0 into S1 minus S2, and if you, this would also be a minus, so this would be minus T0. So this is the value of Q. Okay, so let's put this value over here. So after putting that value of Q over there, the value of W, it becomes minus T0 S gen minus T0 into S1 minus S2, okay, and then plus E1 minus E2. So this is the work done. Now this is the work done when going from state 1 to state 2. Now during this work, there is also some surrounding work. So the surrounding work that is being done in going from state 1 to state 2 is P0 V2 minus V1. Okay, so the useful work that you get, because that is what we want, to find out the availability. So that is equal to work in going from 1 to 2 minus the surrounding work. So if you put these values, so this becomes W useful, that's the availability, minus T0 entropy generation, minus T0 into S1 minus S2 plus E1 minus E2, E1 minus E2, okay, and then you have minus P0 into V2 minus V1. So this is the expression for the availability or the available energy of a system. Okay, so this is how you derive the mathematical expression for availability of a system. You have entropy generation, you have entropy change, you have internal energy change, and then you have the surrounding work over here. Okay, so I hope you understood this entire mathematical derivation to get to this expression. Now, in the next video, we look at the availability of a closed system.